Hello everyone. In the series of IoT, today let's discuss about ultrasonic sensor. So our model is HC-SR04. So before interfacing, let's look at what is meant by ultrasonic sensor. Ultrasonic sensor is used to detect the object. Along with the detection, it can find the distance in between object as well as sensor. The working principle is same as bad echolocation. So it is sending the sound waves in the free air and hitting the target within the range if it is there, and the sound waves are reflected back which are collected by the sensor. So that is the basic work principle of sensor. So this is the sensor is sending the sound waves in the air at the speed of 344 meters per second. So this is the sensor comes with the low cost and easy to handle, easy to interface, so more user friendly. Let's look at the specifications of ultrasonic sensor. So it is operating with the 5 volts DC and current 50 milliamperes, and the operating clock frequency is 40 kilohertz, and it can detect within the range of 2 centimeters to 400 centimeters range, and the accuracy of detection plus or minus 3 mm, and it can detect the object within the angle of 15 degrees. So if you go for the pin description, it comes with the 4 pins. These 4 pins are VCC, ground, trigger, echo line. So VCC and ground, we can provide 5 volts to the ultrasonic sensor, trigger for initialization. So we can send one clock pulse to the trigger pin from the microcontroller, so that the sensor will emit 8 ultrasonic pulses at 40 kilohertz. So trigger, now here trigger acts as a output line and echo acts as a input line with respect to the Arduino. The role of trigger is we have to send 10 microseconds high signal to the trigger pin so that the sensor emit 8 ultrasonic pulses at 40 kilohertz, and then the ultrasonic sensor sound waves hit an object and reflect back. So let's go to the timing diagram of a ultrasonic sensor. See, this is the timing diagram for ultrasonic sensor. So from the microcontroller, we have to send one active high pulse. This is the active high pulse. Initially, it is at low, and then it is going to high pulse. Maintain the high pulse at least 10 microseconds, and then make it low. After initiation of the trigger, the sensor emits 8 ultrasonic pulses at 40 kHz. So because in order to generate the sound waves effectively, it is taking 8 clock pulses generation at 40 kHz. Now the sound waves are travel in air. After generation of sound waves, immediately at echo pin it goes to high. Here it goes to high. So it is maintaining active high pulse at echo line until the sound waves are reflected back. So the sensor can detect up to 400 centimeters range. Within that range, if any obstacle is there, the sound waves are hitting the target and reflected back, and which are collected by the receiver. So whenever it is receiving, then immediately the echo pin goes to high. So during this is the time period, the sound waves are travel in the air. So based on this time duration, we can measure the distance between obstacle as well as sensor. So actually, on module of ultrasonic, we have a timer circuit. So when echo pin goes to high, then immediately that will turn on the time. Okay, so the sound waves are traveling in the air, hitting the target and reflected back. During that time, the timer is running, and once the reflected waves are collected, the echo signal pin goes to low. So now the timer calculating the active high pulse of the echo signal. Based on that, it is going to find out the distance. So we have a formula for distance. Distance equals to speed into time. So time into speed of the sound waves. So initially in the air, the sound waves are traveling at with the speed of 343 meters per second. That is the sound waves speed in the air. Now let's look on to the programming part. So we have two pins. One is trigger pin. Initially define the pins. So I'm taking trigger pin as well as echo pin according to my hardware connection, which are connected to pin number 3 and pin number 2. LED for notification that was connected to pin number 13. Okay, and for the calculation of distance and the duration, I'm defining two variables, duration as well as distance. And coming to the pin mode, define trigger pin as output and echo pin as a input. And to check out the distance in the monitor, I'm using this one, serial communication port. And coming to the main program, as per the timing diagram, so what we have to do, send active high pulse to the trigger line. First it is at the active low pulse, then it is going to high, maintain high pulse at least 10 microseconds and make it low. So first one is active low pulse, that's why I'm sending low signal to the trigger pin, and at least we should maintain the active low pulse 2 microseconds, and then send active high pulse and the active high pulse duration at least 10 microseconds, and then low pulse. So in this way we can send one clock pulse to the trigger line, and after completion of this scenario, the sensor will emit 8 clock pulses, 8 series of clock pulses at 40 kHz in order to generate the sound waves. At the same time, it goes high at the echo pin. So we have to capture that echo high signal, high pulse. So I'm going to calculate the time duration of a sound waves, how much time they traveling towards the object and reflected back. Okay. So now duration equals to pulsing at echo pin, and I want to capture high pulse at echo pin. Okay, so now finally we have a time duration of the sound waves by this variable. Now calculate the distance. Distance equals to time duration into speed. The sound wave speed in the air is 0.0343 centimeters per microseconds. So finally that is divided by 2, because one time the sound waves are traveled in the forward direction to hit the target, and second time reflected back. But we want to calculate only one time. That's why it is divided by 2. Okay, after calculation, I want to display the distance from sensor to object in a serial monitor. So for printing, I'm using this functions. Okay, after some time delay, I'm checking the condition. If the distance is less than 100 centimeters, what distance? The distance between sensor as well as obstacle. If the distance is less than 100 centimeters, then turn on LED. If not, turn off the LED. That is the complete code. For the better visualization, this time I'm using Tinkercad. It is online platform. Here you can hack the circuits and you can write the code itself. So we have to log in with your email, and after that come to design portion, and in the design portion, this is the circuit here. Whatever the components you required, you can fetch with the keywords. In this one, I'm taking LED, and whatever the components are required, you can fetch with the keywords, and simply you can drag and mix. After that, give the connections. Okay. So VCC, ground, trigger line, echo line, and register. So through register, I'm connecting the LED module. Right. Let's see the simulation board. I already are connected, and here you can write the code, you can paste the code, so write the code and then start the simulation. So in the simulation part, I want to check out the distance in the serial monitor. Now the distance is 38.24 centimeters. Click on here, you can see the animation over there. Now the distance 165 centimeters. This is the detection angle up to 15 centimeters. 240, right? You can see the uh, movement of the object. Now closely we observe closely we observe the status of LED is off when the obstacle coming to the within the range of 100 centimeters. You can see the status of LED. Now it is an on condition. Small blink is there. If it is out of 100 centimeters, the same LED comes to off. You can see the same status. In this way, we can interface and easily we can write the code. And also with this sensor we can implement different applications, and with this we can find out the water level indication. You guys, you try to implement